The application of irrigation technology in some countries has experienced a shift in line with various irrigation water management problems. Open channel irrigation system has changed to the piping system. Surface irrigation system, be it furrow, border, and basin irrigation systems, turn toward the pressurized irrigation system, namely sprinkle irrigation and drip irrigation. In Indonesia, the efficiency of surface irrigation system is around 40 to 45%, while the furrow system is around 60 to 62%. In the future, the efficiency of irrigation in Indonesia should be improved to anticipate the lack of irrigation water during dry season. The application of drip irrigation is expected to increase irrigation efficiency up to 90%. Viewed from technical aspect, the technical character of the soil physical condition, agroclimate, and water resources, the drip irrigation system has the prospect to be developed in several regions in Indonesia, particularly in some areas with limited water resources. Theoretically, drip irrigation efficiency is higher than the surface irrigation or sprinkle irrigation efficiency, which is greater than 95%. In addition to reducing water loss in the form of percolation and runoff, drip irrigation system only deliver water on the root area, thereby reducing the loss of irrigation water in the area of land that is not effective for plant growth. However, in its application, relatively high efficiency value of drip irrigation can only be achieved if it meets the right design and proper operation. Drip irrigation or trickle irrigation is a way of giving water to the plant, either directly on the ground surface or in the subsurface through droplets continuously and slowly in the soil near the plants. Once out of the dripper or emitter, the water spread into the soil face horizontally and vertically due capillarity rise and gravity. The area wetted by dripper depends on the magnitude of the emitter discharge, the type of soil structure and texture, soil moisture, and soil permeability. There are several advantages of drip irrigation system. Among others, the efficiency in the use of irrigation water is relatively high compared to other irrigation systems. It can reduce the activity of plant pests since the area wetted just around the root zone only. Drip irrigation system can increase the effectiveness and efficiency of fertilizer and pesticides as can be given simultaneously with irrigation water and only given in the root zone. The drip irrigation system can save manpower requirements for the function of providing irrigation and fertilization as the system can be operated in an automated way. The supply of water can reduce the risk of sustained accumulation of salts and other toxic elements in the root zone of plants. Well adapted to the topography and the nature of the plant growth media with the support of highly skilled labor force, the system has a very high accuracy in determining the timing and amount of irrigation that should be given to the plant. In addition to the advantages, there are also weaknesses or deficiencies of drip irrigation system which require intensive care. Blockage of the dripper is a problem that often occurs in drip irrigation as it will affect the discharge and the uniformity of water distribution. It requires intensive care to a drip irrigation network so that the risk of blockage can be minimized. Stacking salt. If the water used contains a high salt and also used in dry areas, the risk of salt buildup can be high, limiting the growth plants. The limited supply of water on drip irrigation water raises the risk of water shortage if the water needs not carefully calculated. And last, namely cost and technical limitations, drip irrigation system requires high investments in development. Also requires high techniques in design, operation, and maintenance. The provision of water in drip irrigation are performed using an application or so-called emission devices. They can provide water with a low flow and frequency which almost continuously around the plant roots. The water pressure coming into the application tool in around 1 bar and removed in close to zero pressure to get a trickle of continuous and low discharge, so that drip irrigation is classified as low pressure irrigation. Drip irrigation components that are typically used are pumping stations, pressure regulator made in sub-main pipe, lateral pipe, dripper, valves, joints, and other ancillary equipments. For all types of drip irrigation, the lateral pipes are connected to the water supply pipe, which is called manifold. The main unit or head unit. The main unit consists of pumps, tanks injection, filter or main filter, and control components or pressure gauges, flow meter, and valves. Pumps and propulsion functioning in lifting water from the source. Furthermore, water channeled to land through a network of piping. The main pipe or main line. The main pipe is generally made of polyvinyl chloride or PVC pipe, galvanized steel or cast iron in a diameter of between 7.5 to 25 centimeters. The main pipe can be installed above or below ground level. The main pipe is a component that delivers water from the source to the pipes in the distribution network. Distribution pipe or subunit manifold. Distribution pipe supplemented by a second finer filter, which is the size of 80 to 100 micrometers. Then the solenoid valve, pressure regulator, pressure gauge, and the exhaust valve. The main sub-pipes made of PVC or HDPE pipes are so-called high-density polyethylene with a diameter of between 50 to 75 millimeters. Distribution pipe is also a pipe with many expanses such as lateral pipes. Distribution pipe may consist of 1, 2, 3, or 4 pipe sizes. Lateral pipe. Lateral pipe is a pipe installed in the application tool. Generally, from polyethylene or PVC pipe, its diameter is 12.7 millimeters up to 38.1 millimeters and equipped with exhaust valve. Piping network of a pipeline manifold to several lateral pipelines referred as subunit. Lateral pipes carry water from the main pipe and the distribution pipe to the tool application. The main factor causing variations in the discharge of an application tool along the lateral pipe is the pressure difference along the pipeline operation. It is caused due to friction, losing minor, and the elevation difference. Generally, the lateral pipe has a uniform diameter. The use of multiple diameter pipes can reduce the investment cost. However, the use of more than 2 pipe diameter becomes impractical on gentle slopes in the direction of the lateral pipe that is less than 3%. Both lateral pipe can have the same length because the operating pressure at both ends of the lateral pipe is relatively the same. While on a slope in the direction of the large lateral pipe, ascending lateral pipe or upslope will be shorter than the declining pipe or downslope. Application devices. Tools application consists of a dripper, ammeter, small pipes, small chips or bubbler, and small sprayers, and micro sprinkler which mounted on the lateral pipe. Ammeter or dripper is a component that delivers water from the lateral pipe to the ground around the plant continuously and in low debit with close to atmospheric pressure. Dripper, generally classified by the mechanism and spreading pressure. Single dripper can irrigate a small area or can be installed around larger plants such as double or multi-dripper. Double dripper, generally used for shrubs, and multi-dripper used for fruit trees.
Kalau petani biasa, Pak, kalau nggak ada bantuan dari pemerintah, mungkin warga petani salak yang nggak mampu untuk membeli saluran tetes yang contohnya seperti yang ada di belakang rumah itu. Enak mestinya hasil ya maksimal ya saya sing irigasi tetes karena kan napa niku kebutuhan tanaman salak saged tercukupi. Itu mungkin yang agak sulit itu untuk beli mencari itu selang yang kecil yang tersalur pada pohon-pohon.